Welcome to ZYLIA Beamformer. In this tutorial, you'll learn how to spatially filter and separate Ambisonics B format signals from first order, 4 channels, up to 7th order, 64 channels, using our new plugin. Here's the main interface. The central radar lets you steer microphones in 3D space. The right-hand list shows all active virtual microphones, and the bottom panel exposes precise position and separation controls. To add a virtual microphone, click the Add Microphone button or the plus icon in the radar. You can create up to 24 microphones, each independently positioned and tuned. Select a microphone, then drag its icon around the radar to set azimuth. Use the elevation and width sliders to fine-tune vertical angle and beam opening. Narrow widths deliver tight focus. Wider beams capture more ambience. Enable source localization to auto-detect up to 24 simultaneous sound sources. Each detected source appears as a blue plus marker. Click one to instantly create and position a microphone at that location. Each virtual microphone outputs to its own DAW channel. Click the output label, Z1, Z2, and so on, to route it to the corresponding track in your session, where you can record or automate its parameters. Now, let's dive deeper into separation mode. This setting determines how the sound separation algorithm behaves when you have multiple virtual microphones active. In S1 mode, Beamformer actively cancels sounds arriving from the directions covered by your other microphones. This delivers excellent spill rejection between sources, but it's best used in rooms with low reverberation and with a moderate microphone count. Too many microphones or very diffuse reflections can overload the complex computations. And if two sources end up closer than 15 degrees, Beamformer will automatically switch from S1 to S2 to maintain stability. In S2 mode, the focus shifts to attenuating all off-axis energy, regardless of where your other microphones are pointed. S2 is ideal for taming diffuse background noise and reverberation, scales efficiently when you're using many microphones, and plays nicely with automation of azimuth, elevation, and width. Switch to Omni mode when you want an entirely non-directional pickup. Here, all angle parameters are ignored and your microphone responds equally in every direction. Finally, the separation level control adds a layer of processing that simulates close microphone behavior. Set it to high to maximize background suppression and accentuate source isolation. Just be aware that this blind source separation algorithm is non-linear and may introduce subtle timbral coloration. Click Polar Pattern to view the real-time sensitivity curve of any microphone. Watch how width and mode sculpt the lobes. Use this to confirm you're capturing exactly where you want. Toggle the energy map to display a heat map of acoustic energy around your array, ideal for rough placement before you dive into fine-grained microphone steering. Insert Beamformer on a multi-channel track that matches your Ambisonics order and supports up to 64 inputs. Prepare separate audio tracks for each output, Z1 through Z24 and beyond, if needed. Then route them so you're ready to mix or record. For advanced setups, open OSC settings to configure open sound control. You can send commands to move microphones or receive live source positions, enabling custom remote control and integration in interactive installations. That wraps up our deep dive into ZYLIA Beamformer. Powerful spatial filtering and separation for Ambisonics orders 1 through 7. Now it's your turn. Experiment, automate, and bring your immersive audio projects to life. Thanks for watching.